Hi everyone, this is 3.1 redox reaction part 2 video. In this video, I will focus on the fourth definition, redox reaction based on increase or decrease of oxidation number. But before we can discuss that, we must first understand the meaning of oxidation number, or you can also say that as oxidation state. Well, oxidation number refers to the charge that the atom would have if complete transfer of electron occur. Take one compound for example, such as magnesium oxide. So now you want to find out what is the oxidation number of magnesium and what is the oxidation number of oxygen in this compound. Okay, well, if you can recall the formation of ionic compound in Form 4, Chapter 5 Chemical Bond, metals such as magnesium will donate electron to become positive magnesium 2+ ion, and non-metals such as oxygen will gain electron to become negative ion. So magnesium lose electron or lose 2 electron, and oxygen gain 2 electron. And what is effectively happening is magnesium basically transfer its electron to oxygen, so that both magnesium and oxygen achieve stable octet electron arrangement. Now, both magnesium 2+ and O2- ion will be attracted to be Mg or compound. So, moving back to the definition of oxidation number, Mg will carry +2 charge if complete transfer of electron occur. Oxygen will have -2 charge. So we can say that the oxidation number of magnesium is +2 and the oxidation number of oxygen is -2. There are 5 rules to help us to assign the oxidation number of an element in a compound. So rule number 1, the oxidation number of an element is always 0. So all these elements in its elemental state or even in a molecule, here is the molecule, this side here is atom, are all equals to 0. Okay, moving on to rules number 2. For a simple ion with a single atom referring to monoatomic ion. So all this is a monoatomic ion. The oxidation number is equal to the oxidation state. For example, Cu2+ charge, so the oxidation state is equal to the charge +2. Br- -1. Oxygen 2- charge, so oxidation number is also 2-. Aluminium ion, the charge is +3, so the oxidation state is also +3. Now, rule number 3, the sum of oxidation number in atoms or molecule that is neutral is 0. So all this molecule or compound, the sum is 0. For example, H2O, oxidation number of H is +1, but there are 2 H, so R times 2, and oxidation number of oxygen is -2. And the sum of this oxidation number is equals to 0. So the sum of the oxidation number of atoms or molecules that are neutral is always 0. Moving on to rules number 4. Some elements almost always have the same oxidation states in their compound. This is especially true for compounds like hydrogen and oxygen. Hydrogen always have +1 oxidation number with some exception, and oxygen always have -2 oxidation number with some exception. So hydrogen is always +1 except in metal hydride, and oxygen is always -2 except in peroxide. So let's look at some example for hydrogen. For example, in HCl, H is +1, so Cl is -1. But in metal hydride, such as NaH, for example, Na will be +1, so hydrogen is -1. Because sodium is a very electropositive metal. But this happens in a very few cases. Most of the time, the oxidation number of hydrogen is always +1. For oxygen, such as in zinc oxide, zinc is +2, so oxygen is -2. But in some exceptions, such as hydrogen peroxide, oxygen is +1, but there are 2, so that become +2, and oxygen is -2, but then there are 2 oxygen, so that is -1 for each of the oxygen. So if I make myself clear again, hydrogen is always +1. Oxygen is always -2, except in peroxide it will be -1. And hydrogen is always +1, except in metal hydride it is -1. And then the last rule, rule number 5, the sum of oxidation number of all the atoms in an ion is equal to the charge on the ion. In this case, there's a polyatomic ion. So the charge of nitrate ion, -1. So the sum of oxidation number is also -1. Carbonate, the charge of the ion is -2, so the sum is also -2. Phosphate, the charge is -3, so the sum of the oxidation number is also -3. And ammonium ion, the charge is +1, so the sum is also +1. And you will see this rule will come on very handy in our next example. So before we go on example of question, first let us review the 5 rules to assign the oxidation number of an atom or an element in a compound. So the first one, the element in its elemental form is always 0, and it could be in atom or in molecule form. Second, for monoatomic ion, the charge of the ion will be the oxidation state of the ion. Rule number 3, for neutral compound, the sum of the oxidation number is always 0. The fourth one, oxygen is always -2, except in peroxide where it will be -1. And hydrogen is always +1 except in metal hydride where it will be -1. And the last rule, rules number 5, for polyatomic ion, the sum is equal to the charge of the polyatomic ion. So with that, we are ready to try on the first example. The first example is from SPM 2009, paper 1, question 9. And it asks what is the oxidation number of hydrogen in magnesium hydride. So if magnesium is +2, this 2 hydrogen is -2. If 2 hydrogen is -2, just a single hydrogen is -1. So the oxidation number of hydrogen in magnesium hydride is -1. And that will be the exception. If you remember that we learned just now, hydrogen is always +1 except in hydride where it will be -1. Okay, moving on to our second example. What is the oxidation number of X in XO4 to minus? Okay, so the first rule that we will apply is in XO4 is the sum is equals to the charge of the ion. Sum of the oxidation number is equal to the charge of the ion. So whatever is the oxidation number of X, I'm going to give X plus 4 times the oxidation number of oxygen is -2 and equals to the charge of the polyatomic ion. The sum of the oxidation number equal to the charge of the polyatomic ion, which is -1. So X minus 8 equals to -1. So the oxidation number of X is -1 plus 8 equals to +7. So the answer is C. Moving on, in SPM 2018, question 21, what is the change in oxidation number of hydrogen? So this question requires us to know what is the oxidation number before and after the reaction, and in this specifically for hydrogen. Okay, the oxidation number of zinc is 0 in its elemental form. The oxidation number of hydrogen ions will equals to its charge, which is +1. Zinc will be equal to its charge, which is +2. And hydrogen in its elemental form as a molecule is 0. So oxidation number of hydrogen from +1 to 0. So that is C, +1 to 0. So I'll just like to recall the rules for zinc and hydrogen is oxidation number is 0 because this is in its element form, and that is rules number 1. For H plus and zinc 2 plus, the oxidation number is equals to its charge. Where H is +1, zinc is +2, and this is rules number 2, where the charge will be the oxidation number. So now I would like to relate the oxidation number with IUPAC nomenclature of compound. If you remember in Form 4, Chapter 4, Periodic Table of Elements, transition metal exhibit the special characteristic where transition element or transition metal have more than one oxidation number in their compound. So copper, for example, can be the oxidation number can be +1 or +2. So the Roman numerical figure written in bracket after the name of the element will refer to the oxidation number. So copper 1 oxide means the oxidation number is +1. Copper 2 oxide means the oxidation number of copper is +2. Well, now that we have learned all 5 rules to assign oxidation number of an atom in a compound, now we can learn the 4th definition of redox reaction, which is based on increase or decrease of oxidation number. When the oxidation number of an atom increase, the atom in a compound undergo oxidation. And when the oxidation number of an atom in a compound decreases, the atom in that compound undergo reduction. To make this easier for you, the word reduction, reduce, refer to decrease in oxidation number. So the example is reaction of magnesium with hydrochloric acid. So we must first determine the oxidation number of all these reactants before the reaction and oxidation number of the product after the reaction. And then by comparing the oxidation number before and after, we can see whether the oxidation number increases, which is an oxidation process, or the oxidation number decreases, which is a reduction process. Okay, so we will start with magnesium. Magnesium is in its elemental state, so the oxidation number of elemental state is always 0. And so is hydrogen. Even though hydrogen is a molecule, but this molecule is in its elemental state, so the oxidation number is also 0. Hydrogen is always +1, while chloride ion is -1. Magnesium ion is always +2, and chloride is -1. And you will notice here that the oxidation number of chloride before and the oxidation number of chloride after doesn't change, which means chloride doesn't undergo oxidation or reduction. Okay, so since oxidation number of magnesium before is 0 and after is +2, so oxidation number of magnesium increases, and hydrogen ion, the oxidation number decreases from +1 to 0. So oxidation number decreases. So magnesium become Mg to plus ion. Is an oxidation process because the oxidation number increases from 0 to +2. Well, hydrogen become H2 is a reduction because the oxidation number decreases from +1 to 0. And I will just complete that half equation. Sorry. So in this case, magnesium is undergo oxidation, so magnesium is the reducing agent. H plus ion undergo reduction, so hydrochloric acid is the oxidizing agent. So I hope that have helped you to understand the redox reaction based on increase or decrease of oxidation number. We will work on another example, which is the reaction between chlorine water and potassium bromide solution. So in this reaction also, we will try to determine the oxidation number before and after the reaction. So chlorine in its elemental form as 0, and so its bromine molecule in its elemental form is also 0. Potassium ion is +1, bromide ion is -1, potassium again is +1, and chloride is -1. And you will notice that the oxidation number of potassium does not change before and after the reaction. So potassium doesn't undergo oxidation or reduction. So the oxidation number of chlorine decreases from 0 to -1. So chlorine undergo reduction, and at the same time act as oxidizing agent. Chlorine water is actually a very good oxidizing agent, as you will remember the bleach, household bleach that you use to bleach clothes actually contain chloride ion. That is a very actually contain chlorine water that is very strong as an oxidizing agent. Next is the oxidation number of bromide ion, Br-. increases from -1 to 0. So bromide ion, Br minus, undergo oxidation and itself act as reducing agent. Next, we will learn why neutralization is not a redox reaction. So first, we will determine the oxidation number on the reactant side and the oxidation number on the product side. Oxidation number of sodium ion is +1. And oxidation number of oxygen is always -2. Hydrogen is always +1. Again, +1. Chloride is -1. Sodium is +1. Chloride is -1. Hydrogen is +1. Oxygen is -2. So we will see here that the oxidation number of sodium before the reaction is +1 and after the reaction is also +1. The oxidation number of oxygen before is -2 and after is still -2. The oxidation number of chloride before is -1 and after is still -1. And the hydrogen before is +1, after is still +1. So we can summarize that neutralization is not a redox reaction because the oxidation number of all atoms in the compound remain the same or do not change in the reaction or during the reaction. So that is all for today. Thank you very much for watching this video, and I would just like to remind you to stay home and be kind. And if you have any question, and please write them in the comment below, and I will respond to them as soon as I can along our online learning session. And also please don't forget to like and subscribe. Thank you.